Good afternoon to you. I am Mark Sudduth in Wilmington, North Carolina. It is Monday, the third day now of April 2023, and today's main topic is going to be Category 5 Hurricane Ian. Cat 5, you might be wondering, where did that come from? Well, the National Hurricane Center has gone back and looked at additional information, as they always do in the off-season, and they have determined that briefly Ian made it to Cat 5 status for about 6 hours or so just off the southwest coast of Florida. They looked at a whole bunch of information. We'll dig a little deeper, and I'll show you some of that info in just a moment. But yes, Ian was now, or is now, officially a Category 5 for the history books. But very briefly, it weakened to a 4 right before landfall, and of course it was very destructive. I think it's third on the list overall, behind Katrina and Harvey. And of course it was deadly as well. Several dozen people lost their lives. That part to me is unacceptable. It's completely preventable. But that's a story for another day. Today, let's take a look at the details, the technical aspects as to exactly why Ian was upgraded to a Category 5. All right? First of all, this tweet here from Dylan, my friend down. Well, he's not in Southwest Florida any longer. He's going to be going elsewhere. You might have seen a report or a tweet from him recently. He's moving somewhere else. I'll let him tell you that. But he used to be down there. We worked with Dylan, my colleague Matt and I, to get stuff set up for Ian. So Dylan tweeted this, as a lot of other people did when it came out this morning. National Hurricane Center finds that Ian became a Cat 5 just offshore, and that's very important there, just offshore Southwest Florida. But, or as Dylan says, however, it weakened to a 4 by the time it made landfall. So let's take a look here at a couple of stats. This is from our very own CJ that put this together for us on our back-end team. Top winds were 161 miles per hour. What is that all about? 161? They're really measuring that accurately? No, that's what you get if you take 140 knots, which is how the National Hurricane Center reports on these different systems. It's in knots, and then of course you can convert that to miles per hour by multiplying 140 times 1.15. You get 161. It's a Category 5. The difference between a 4 and a 5, 155, 160, you won't feel it. You won't notice it out there. But scientifically, there was enough data, and I'll show you some of that in just a moment in a really nice screen capture from the report. It digs deep into some of this information. Maximum surge was 15 feet. That's up there in Lee County. Probably that is occurring over in the Fort Myers Beach area. The gradient, or the distribution of surge over distance, was pretty remarkable. Only a few feet, for example, at Captiva, several more feet than that at Sanibel. I don't have the exact numbers, but then just down in Fort Myers Beach, as we saw from Max Olson's unbelievable footage that he captured there on a similar device to a GoPro, we're looking at about 15 feet of surge, and then down into Collier County, 6 to 8 feet or so. And what's concerning, we put a bunch of cameras out there. There's one of them right behind me. That's one of the boxes that we use. That one's actually from Hurricane Michael, just in case you're wondering. The very infamous shot there from Mexico Beach. Other people are putting cameras out. Max was doing that. The folks over at Severe Studios put cameras out. And that's a good thing. It really is. The more of this that we can see in the future, the better. But what really bothers me and is concerning to me is how many pictures and videos of surge that we saw from devices just like this. There's some weird fascination, I guess, now with filming raw Mother Nature and putting it out there on social media to get viral. Or maybe we're just curious creatures. I don't know. I'm not a social scientist. At the core of what I do study a little bit about what people do and why they do it. But the video that came out from people staying behind was very concerning as well. Anyway, the maximum surge there, 15 feet. Sorry, I got off on a little tangent there. And I'll explain a little bit more why in just a moment. And then the rainfall was close to 27 inches. Ian produced tremendous flooding across Florida. And then, of course, it made a second landfall up in South Carolina. Let's not forget that. But in Florida, the main impacts here, as you can see outlined by this graphic, are pretty substantial. Now, the air pressure, 937 millibars, not particularly low for a Category 5 hurricane. I mean, Katrina's air pressure, for example, was in the 920s as it made the first landfall in southeast Louisiana, but it was a Category 3 hurricane at that landfall, if memory serves. And there's a lot of reasons why. The pressure-wind relationship, the structure of the hurricane, how it's undergoing rapid intensification, all that kind of stuff. Is it winding up or is it unwinding? All of these things matter, and that's what the National Hurricane Center scientists do. They dig in, they go through all these reports, and there's a lot more data now than ever before. So let's take a look at what some of that data is. Here is that screen capture that I wanted to show you, and I want to cite where it came from. I appreciate that people do this kind of stuff and make my job a lot easier there. So let's click on the screen cap and I'll show you. So why was it upgraded? So I'm just going to read this to you, so bear with me here. Ian's estimated peak intensity of 140 knots, and that's what I was talking about, 140 knots, so that's 161 miles per hour if you put it in a calculator, and the minimum central pressure of 937 millibars at 12 UTC, so that's 8 a.m. Eastern Time on the 28th of September, are based on data from the Air Force Reserve Unit and the NOAA reconnaissance aircraft. During the missions, the maximum 10-second average flight level winds reported in the hurricane's core were 160 knot from the NOAA aircraft at 750 millibars. That's an altitude of about 6,800 feet. I love that they put that kind of information in there. Thank you, National Hurricane Center folks. And then at 10:13, I'm sorry, that was recorded that was all done at 10:13 UTC on the 28th of September. So all of this information is based on that observation at that time, which is universal time, of course. These flight level winds support a surface intensity estimate of 136 knots. There were also multiple peak stepped frequency microwave radiometer surface wind estimates from both Air Force and NOAA aircraft of 137 to 138 knots at 10:30 UTC and 10:13 UTC. You can see what I'm saying. This is very detailed here. They don't just throw darts at a board. The step frequency microwave radiometer data from the Air Force instrument was flagged as unreliable, and I'm going to make this red right here, in the real-time products. But reprocessing in the post-storm analysis, underline that too in red because it's important, using an updated algorithm no longer flagged the peak values. Due to extreme turbulence in the region, and if you guys remember that, the planes reported just crazy turbulence out there, where the maximum sustained winds were located in the western quadrant. Due to that, the aircraft was only able to sample that part of Ian's core once. So let's just stop for a second. It was very violent. The aircraft, and they've gone through a lot of hurricanes with these, they were really worried about structural integrity, and they couldn't sample it except one time. That is such a small moment in time over a very small area of a very changeable environment. So it's possible that Ian had stronger 10-second averaged winds than what they were able to record. So I think this is all very good, deep information here. It really helps us to understand this is not done to satisfy some weird need to upgrade stuff. There have been storms that have been downgraded. All right, so let's just continue reading, okay? So they were only able to sample that core once. A profile of the winds from the NOAA P3 tail Doppler radar showed a shallow maximum of winds largely below the aircraft altitude, with speeds exceeding 160 knots, only 500 to 1,000 feet above the surface. Now, let me just talk about that for just a second. For folks in areas with tall buildings, I'm looking at you, Miami and Fort Lauderdale, but especially Miami. And I know that even Southwest Florida, certainly Tampa on the west coast, a little farther up the coast, from where Ian made landfall, have some tall buildings. But these numbers right here, I don't say this very often, but they should scare you. They really should. Because 500 to 1,000 feet, you're getting into where some of these tall, modern-day skyscrapers are, and we're talking about Category 5 wind at those elevations. So what if you absolutely have a Cat 5 operationally while it is happening, like Dorian, and you bring that core into West Palm Beach, Fort Lauderdale, or downtown Miami proper, where they are building incredible skyscrapers. They have built them. They are building new ones. I've seen it. And some of them I've actually been into back in Irma. Also a story for another day. But this is very concerning. We're getting these Cat 5 winds now where people reside in some of these very tall structures. And of course, there's not as much friction up there and we could have some really, really big problems. As bad as Ian was, as bad as Dorian was, especially for our friends in the Bahamas, I think we're still sitting on a razor-thin margin here before we get a truly catastrophic event in a major metropolitan area such as Miami, possibly Houston, Tampa, New Orleans, although New Orleans doesn't have quite as tall a set of buildings. Anyway, back to the analysis real quick here. So at that elevation, 500 to 1,000 feet, 160 knots of winds, the combination of these data and the consideration of potential undersampling from the SFMR support a peak intensity of 140 knots. It should be noted that the NHC best track intensities typically have an uncertainty of around 10%. I tried to scroll over it and highlight it. That's funny. Around 10%. And that there is very little practical difference, is what I was talking about, between a 140 knot Cat 5 and a 135 knot Cat 4. You're just not going to notice the difference in real time. So there you go. That is the reasoning, at least in that particular paragraph, and I appreciate the tweet here very much, as to why Ian was upgraded. Moving along, just a couple of sort of posterity-type tweets from Jacob here. A suddenly rare radar image. Right, exactly. If anybody saved these, you now have some history. High-resolution NextRad image of Category 5, as we know now, Hurricane Ian. And here's some of your other data. Just wow. I mean, it's incredible. You know, what we saw there in person. Now, speaking of in person, so real quickly, I am going to be presenting this. This is a screen capture from my software editing program that I use from Adobe. I'm putting together a presentation for the National Hurricane Conference where I will be presenting on Thursday at a luncheon, actually co-presenting with Dr. Phil Klotzbach, so that's kind of a cool honor. And I'm going to go over a lot of different storm surge examples from the past 18 years. Hard to believe it's been that long since we started this project with the unmanned cameras. But I figured I'm going to show you just a couple of examples here to remind you of what happened there. And we talk about wind, and of course we had the surge. This is in Fort Myers. We had a remote cam, and this is what it looked like just later on that afternoon. The water came up 6 to 7 feet above ground level right there in Fort Myers. And of course, remember what happened. You know, it was very damaging and very impactful. And as I said, unfortunately, many dozens of people lost their lives, especially out there at the immediate coastline in Lee County and elsewhere. And of course, people are still struggling even today. These hurricanes leave a long and lasting scar long after they're gone. So I will put a link in case you want to read the full discussion, the full TCR as it is known, the Tropical Cyclone Report. I will put a link to that in today's video update on YouTube, all right? So what's happening out there today? We're going to talk a little bit more about the tropics, and then we're going to switch gears over to severe weather real quick. Luckily, it's not hurricane season yet, but we are now inside of the 2-month period. We're less than 60 days to go. So we will begin watching some of the models and other pieces of guidance that are out there. Once we get into May, we'll start to watch this area very closely, as well as the southeastern Pacific. We're about a month away from that. That's hard to believe. And the way things are going, it wouldn't surprise me to have a May storm event either in the eastern Pacific or the western Caribbean. We'll wait and see about that. But that's the areas that we're going to be watching closely as we get closer to the start of the hurricane season. All right, so this is just amazing right here. It really is. I continue to talk about this. Of course, we look at this every week. There's the onset of the El Nino trying to make its presence known. A little bit of an erosion right there along the equator of some of those positive anomalies. In other words, it's cooled off just a little bit. And we still have the right at neutral, roughly, Nino 3.4 region out here as it's known, basically. And then a pretty cold relative to average eastern Pacific up into the northern latitudes. Conversely, the Atlantic continues to be warmer than average, especially right here in the eastern Atlantic, and very importantly, right off of the Iberian Peninsula there, these water temperature anomalies running a degree Celsius or higher above the long-term average. The Caribbean Sea proper, pretty much where it should be. The subtropical North Atlantic cooler than average, and that is a very interesting signal that this is cooler, so we'll put a negative here, and this is warmer than average. If this wasn't going to be happening and this was going to be neutral or cold, we would probably be looking at a very, very active hurricane season. But I caution you, we thought we were going to have a very active hurricane season last year, and as nature showed, even when everything seems to line up, there can always be some kind of a monkey wrench or gremlin or some other mystical, metaphorical thing that comes along that you weren't anticipating. And we had basically an average season last year, looking at the last 30 years or so against the averages, and that included Ian. So it just goes to show you. And of course Fiona, we don't want to forget Fiona. Just because it didn't make landfall in the U.S., we don't want to ignore it. But Ian and Fiona were our two benchmark storms last year that was supposed to be a very, very busy year. It wasn't. So I'm not convinced entirely just yet that I got scam calls coming in. It's always fun. I should just put my phone away and ignore it. It's a distraction. It can be. I'm not sure where we're going to go this year, because we do see this signature of a very favorable pattern in the Atlantic. We got the El Nino over here. I need that emoji where the guy is like, wondering. The jury is still out until we develop a solid El Nino, and unless we really start to cool the Atlantic, I think we could still have a pretty active season. And that says nothing about landfalls. The season could be active numbers-wise, and we don't know where they're going to end up or how strong they're going to be when they get there. All right, a couple other things to look at here before we move into the severe weather realm. The SOI does continue to go down. We finally have gone into negative territory on the monthlies as they close those out. So January we were at 11, February we were at 10, and then we lost about 11 points, almost 12 points there. We're now at negative 1.78 for March. And then even the 30-day drop continues here, and we're at -4. Once we get to about -7, the Bureau of Meteorology here in Australia, they typically look at that as an El Nino type setup. Those lower air pressures typically give us more of a westerly wind across the tropical Pacific here, and you're able to make that El Nino happen. That's the short of it. All right, so the SOI headed into the direction of a more El Nino-like situation. And we can see that here from this tweet from Eric Webb. This is that Hofmuller diagram that I tried to explain a little bit last week. And this is nice because at least this product here from Weatherbell that Eric tweeted out shows the Mercator strip of the map here, the tropics. And we're looking between 15 south and 15 north latitude. So that's this area right down here. That's your where geographically this is good for. And then these are your westerly wind anomalies coming in April. All right, that's way out, though, pretty far to the west, depending on your point of view. You see where this is over the maritime continent region, way out in the West Pacific. Farther to the east, easterly winds coming up as we get deeper into April, but in the immediate future, some pretty solid easterlies here. That's what these blues mean, generally. And that encompasses the entirety of the INSO regions. So that's really interesting to me. Meanwhile, we continue the anomalous westerly winds all through time here. This all represents time, and this represents where. You understand that? So this is the present up here, and this is the forecast point. I'm sorry, this is the past, this is the present, and then this is the future down below. I almost completely butchered it. This is all future territory through here. This is where we have been. So just in retrospective, this is what gave us the warming in the Pacific that we see now, and this is what has given us all that warmth in the Atlantic that we see now, and that should continue. But this is really interesting to me. Now, as Eric mentioned in a response to my tweet to him about this, this could induce some serious downwelling. In other words, let me just jump back on here because this gets a little technical. That westerly wind burst that the model is seeing here, the GFS, later on in April, way, way out in the western Pacific, you kind of force those westerly winds onto the Pacific, trying to explain this without getting too deep. It induces sort of a downwelling of the ocean, and to get that deep subsurface warmth to get set into motion. It's like pushing ever so slightly on a very heavy bowling ball. and it can just go down the alley very slowly, especially if that alley is just on a little bit of an incline, right? That's the mechanism there to get the El Nino maybe to really get going. But that's pretty far to the west, and it would take weeks and weeks and weeks for that to manifest itself. And if we get strong easterlies over here along the equatorial region, as the model is indicating, I don't know, it might try to balance itself out. The bottom line, yes, we're still going to have an El Nino, it's almost certain, but to what degree that El Nino truly comes on will determine what kind of a hurricane season we have in the Atlantic, and certainly for the Pacific, not only in the East Pac for hurricanes, and of course in the Western Pacific for the typhoon season out there. All right, let's get over to severe weather quickly as we wrap things up. Tomorrow, this is important, another big day, almost in the same locations, maybe displaced a little bit more to the west in some regards, but do pay attention to the day 2. That's tomorrow. Today's day 1. So we're talking Tuesday here, another possible big outbreak. We look at it over on the SPC site itself. Let's look at today real quick so we don't ignore that. Maybe some thunderstorms producing a few wind gusts, hailstones, and a very, very small likelihood of tornadoes. Nevertheless, 5% is not zero. There's your wind threat, fairly substantial, especially on that I-10 corridor, and maybe some hail, and that includes parts of Texas as well. Tomorrow, that's the main area of concern there. Really, really dangerous once again. Make sure you follow this. If you're out there, you know people traveling there. Severe weather really rearing its ugly head here early and often. March was just crazy, and we're starting April out the same way. This is day 3, and then in the longer time frame, days 4 through 8, luckily, nothing is tripping up the algorithms or whatever they use. I think it's actual people that do all of this mostly, and they do use some machine learning, of course, but at least days 4 through 8, not too active going forward. This is what it looks like on the GFS at the 500 millibar level. There's that energy. That's what's going to come through right there. All of this in here, that's going to trigger what we're going to see on Tuesday right through this area here in the region of the highest ascent in the atmosphere where the air is getting lifted. You got to lift that air. You got to rise it, lift it. You know, that's what ascension is. And then that energy comes in with it, the moisture at the surface. If there's a lot of sun coming in, we call that incoming solar radiation or insolation, then it could be a big day. Now, this is interesting. Let me just show you something real quick. Notice the big fat ridge sitting out here. These are your height lines at this part of the atmosphere. The storm doesn't just barrel across the country. It runs into that ridge, and you can see it kind of changes its shape there. But there it is, and our storm track is up and over like this. We have seen that time and time and time again the last few years. That's why New England has been so much without snow, generally speaking. There's just something about that southwest Atlantic ridge that is changing our winters, making spring storms more down in the mid-south region instead of the traditional tornado alley, and I think that's affecting our hurricane season by helping to make the Gulf of Mexico warmer, driving those tropical systems into the Gulf. Is it all connected? One could make that argument, and I just see that pattern repeating itself. Something to watch for as we progress through April and May for severe weather, and then, of course, into the hurricane season. And speaking of that, we'll end on a tweet from Eric Webb again here regarding severe weather and a little bit related to hurricane season, the Madden-Julian Oscillation, MJO. Details are obviously murky at the moment, but advancing springtime El Nino conditions coupled with a West Pacific MJO is a favorable look for Western Plains dry line setups in the latter half of April. Very interesting. He says, not to mention the huge snowpack out west and the warm Gulf, where have we talked about that a lot, folks, will help temper, I don't know what EML stands for, I admit. That's okay. Will temper the EMLs and increase the moisture. Maybe I should have read more ahead of time, right? And increase moisture recovery advection into the high plains. All of this seems more receptive to mid to late season subtle dryline setups versus the last several years. That's what I was talking about. We had that very strong ridge over the western Atlantic, and most of our activity was down here. I think what Eric is alluding to, we could see a more subtle switch and change to where it's in the more traditional tornado alley area, the western plains, etc. So that'll be something to watch as we go forward. We'll certainly be on top of that as we get through the rest of the month. All right? All right, let me go back over to my title page so I can sign off and get this online for you guys. Again, I will be traveling to New Orleans this week. That's where the National Hurricane Conference is. I mentioned that a little bit earlier. That's down in NOLA this year, the Crescent City. I go down there Wednesday, Thursday, and I do my presentation again at a luncheon with Dr. Klotzbach. If you're going to be at the National Hurricane Conference, be sure to come to that session. I'd love to see you there. I'm going to have about a 22-minute video presentation of all kinds of storm surge examples over the years using these remote cams and kind of posing the question, what do we do with it? We got 18 years of all this data, and we're still getting people staying behind, sort of posing the question, you know, we've got all this technology and all this power, but we're still losing people in storm surge. What's the disconnect? Not that I'm going to be able to solve it all by myself, but I mean, we're showing people these examples, you know, in real time, live in many cases, and yet we still get people staying behind for hurricanes. That's a whole other issue for social scientists to handle. All right? All right. Well, that is it for me for today. Have a great rest of your Monday and a great rest of your week. As always, thanks for tuning in. Don't forget to like, share, and subscribe. Hit the notification button. All that good stuff that all the big YouTubers ask you to do, I'm asking you to do it as well. And a big thank you, too, for watching the video and being a part of our channel. We all appreciate it. I am Mark Suttoth, HurricaneTrack. That's us. I'll talk to you again next Monday.